Hello and welcome to STEM with Mr. N, where I perform different demonstrations and explain the science behind what we're seeing. This week I'm going to look at the science of tornadoes. Let's check it out. Tornadoes are violent spinning columns of air which descend down from thunderstorms. The most violent of these can reach speeds of up to 300 miles per hour. Tornadoes can uproot trees, destroy buildings and throw cars and other vehicles great distances. But what actually causes tornadoes to form? Warm air rises and cold air drops down towards the ground. When you get a lot of warm, moist air rising up and a lot of cold air then dropping down underneath it, the warm air and the cold air meet. This leads to a destabilisation in the atmosphere. At the top of this, there becomes a horizontal spin in the atmosphere. As the cold air and warm air continue to meet, this horizontal spin gets turned into a vertical spin, and that is how we get this air column descending down to the ground. For the first demonstration this week, I'm going to show you how to make a tornado in a bottle. For this, you will require 2 empty plastic bottles of the same size, a jug of water, and the caps for these bottles with the ability to make a hole through them, or you can use a ready-made tornado maker like I am using. The first thing I'm going to do is pour water into one of my bottles until it is about 3/4 full. Then I'm going to screw the tornado maker onto the top. For the next step, I'm going to then screw the other empty bottle into the top of the tornado maker so it is upside down. If you are attempting this demonstration without a tornado maker, you want to put a hole through the middle of both bottle caps and then fill one of your bottles until it is about 3/4 full and put the cap on. Put the cap on your other empty bottle and turn it upside down so that the two holes line up, and then very tightly tape the bottles together. Now that I've got my bottles joined onto my tornado maker, it's time to perform this demonstration. I'm going to tip my bottles so that the one with the water in it is now upside down, spin the bottles quickly and watch what happens. So what is it that is actually happening in this demonstration? Well, when you are emptying out a bottle of water, air is trying to get in and water is trying to come out. Normally, if you just tip a bottle straight upside down, the water and air have to take turns with one going out and one coming in. With the tornado maker or the holes in the lids, you're able to spin the bottles and create a column of air coming up through the middle, just like a tornado. You'll see that we had the vortex coming up through the middle. This allows the air to rush in at the same time as the water is coming out through the sides in the hole, so the air and water are passing in and out of the bottle at the same time. This is a great way to see the shape of a tornado. We can see the spinning vortex going right up through the middle of the water and getting bigger the higher it goes, just like a tornado spreads out and gets bigger the higher up into the clouds it goes. In films, stories and pictures about tornadoes, you might hear about roofs getting ripped off the top of buildings. This is not because of the force of the wind that is pulling the roof off the building. This is because of something called the Benoulli Principle, named after Daniel Bernoulli, who wrote about this in the 1700s. Our next demonstration is going to show the Benoulli Principle in action. For this, you will require 2 balloons, some string and a bit of tape. First, I'm going to blow up both of my balloons and tie them off at the end. Then I'm going to measure out 2 lengths of string to be the same length and tie these onto the ends of my balloon. I'm then going to tape the 2 ends of string onto a table in my kitchen so that the balloons are close but not touching. There is a space in between them. Now what I'm going to do is blow straight through in between the two balloons and watch what happens. You'll have noticed there that when I blew air through in between the two balloons actually came closer together rather than pushing away or staying exactly where they were. This is because of the fluid dynamics described in the Benoulli Principle, which say the faster a fluid moves, the less pressure it has. Because I was blowing air through in between the balloons, I lowered the air pressure in between the balloons. That meant the air pressure on either side of the balloons was stronger than the air pressure in the middle, and it forced the balloons together. This is like what happens to the roofs on buildings during a tornado. Because the air of a tornado is moving very quickly, it lowers the air pressure outside the house. That means the air pressure inside the house is much higher than outside, and it pushes its way up and forces the roof off the building. I have done videos on air pressure before, and I've put links in the description to the air pressure video and the air pressure water fountain video for you to check out. I'd said earlier about the destruction that can be caused by tornadoes, and they can blow things and carry things great distances. But you don't need a tornado for things to just be carried on the wind. Things are regularly being carried on the wind that are much smaller than the likes of what a tornado can carry. The next demonstration is going to show you a way of how you can find out what is being carried on the wind in your area. For this, you will need 2 plastic lids, some petroleum jelly or Vaseline, some string, and a nice windy day. First thing I'm going to do is spread some of the Vaseline inside both of my lids. You'll notice that I'm using plastic lids from drinks cups because they've already got a hole through the middle for me to put my string through. That is the next step of setting this up, as I'm going to cut 2 lengths of string and put a length of string through the middle of each cup so that I will be able to tie these in a loop later. Once both of my cups are set up, I'm going to tie them up somewhere outside where they're not obstructed so that the wind will be able to get to them and blow them around. Once your lids are tied up outside, you can leave them however long you want. I left mine tied up for about 3 to 4 hours because it's not been a particularly windy day here, although the Vaseline still has managed to pick up a couple of things that were getting blown on the wind. This is mainly the seeds from dandelions as they got blown off when the wind was blowing. There were also a couple of small flies which had got caught up in the Vaseline, but I was able to release them without causing them any harm. If you get a magnifying glass and look very closely, you might be able to spot things like dirt and sand also getting caught up in the Vaseline. There hasn't been much of that in mine, partially because it's not been very windy and also partially because of the area that I live in. But you should do this at home or at school and see what gets caught up in your lids. Tornadoes are measured on the Enhanced Fujita or EF scale, based on the amount of damage they cause. This is a 6-point scale ranging from EF0, which causes the least amount of damage, to EF5, which causes the most amount of damage. EF5 tornadoes are very rare and generally only come around once in a lifetime. Although scientists have a decent understanding about what causes tornadoes, there is still a lot that we do not understand about them, such as what causes them to stop. This is why tornadoes are one of the most deadly natural disasters in the world. Well, that's all for this week. I hope you've enjoyed it. As always, I would like to take this opportunity to answer any science questions you have about any science topics at all. So feel free to email me at stemwithmrn@outlook.com and I'll get back to you with answers to your questions. You can subscribe to the channel by pushing the button here, and I've added links here to the other STEM demonstrations I've done so far, and here to my robot review videos. This has been STEM with Mr. N, exploring tornadoes.